Hey everyone, this is problem 9.22 A and C, and we're looking at the producing radioactive isotopes from section 9.2, the nuclear equations in your textbook. Basically, the radioisotopes can be produced in small amounts by converting stable, non-reactive isotopes into radioactive ones. And we do this by a process called transmutation, where you have a stable nucleus that is bombarded by a high-speed particle, such as the alpha particles, the protons, neutrons, and other small nuclei. So the particles that you've hopefully memorized to this point. So when we bombard a stable nucleus, we're going to have a particle that's going to be on our reactant side that's going to be bombarding the stable nuclei. So for problem number 9.22, we have this. We're looking for a question mark there. What can we fill in? Okay. And from bombardment, we know that this is going to have to be a radioactive particle, because that's going to be what's bombarding here's our stable nuclei. Okay, so we do the same thing here. We add up our mass numbers, so everything has to be balanced on both sides. So our mass numbers have to be balanced and the atomic numbers. Okay, so here we have a total of 19 plus 1, 20 is our atomic number total, and 44 would be our mass number, the total from both our nuclei and our proton there. Okay, so now we have to come up with what's going to be fill in the blank here. So we have 40, but yet we need 44. Okay, so we have 40, so we know we're going to have a 4 as our mass number. Okay. We have 20 as our atomic number on the product side. So I'll say this again, that your numbers have to be equal on your reactant side, have to be equal to the product side, okay, or vice versa. So we have 4 as going to have to be our mass number, and then we need 20 total. Okay, and so this equals 44, and we have 18, and we have to equal 20. So we know that we have to have a 2. Okay, so we have a 4 and a 2, which hopefully you know this looks like our alpha particle, which is also the same as the helium atom. And so this is our radioactive, our high energy particle that is going to bombard our stable nuclei. Okay, C is going to be very similar to A. And so we have, this time we're given the particle. So here is our neutron that's going to be, this is our neutron. So this is what's going to do the bombarding. Okay. So we're looking for our stable nuclei that we are going to bombard. Okay. So we add up our mass number. 14 plus 1 is 15. And 6 plus 1 is 7. So we have to have the same numbers on the reactant side. So as of right now, we have 1 plus, E must equal 15, and 0 plus question mark must equal 7. Okay? So if we fill in the blank here, we would have to have a 14, and we have 0 plus 7 equals 7. So our mass number to be 14 and our atomic number 7. So then we go and we find our atomic number of 7 on the periodic table, and that matches up with nitrogen. So this would be our final answer, and this is going to be the element that's bombarded by our high energy neutron. I hope this helps for 9.22.